friends, you are welcome to Royal Learning Channel. My name is Oluwatoyin. In this video, we are going to discuss about 2025 NECO chemistry practical, and we'll be looking at the second aspect of this practical called qualitative analysis, also known as SWOT analysis. I'm going to teach you how to answer questions on qualitative analysis without carrying out the experiment. I taught them like this in WAEC, and what I taught them answered 100% of the question that came out. Please don't overlook this video. If you are watching me on TikTok, to access full video, click on the link in my bio. It will take you to my YouTube channel. If you are watching me on YouTube and you have not yet subscribed to Royal Learning Channel, kindly do so by clicking on the subscribe button to join Royal Learning Channel community. Please don't forget to like this video, share and leave comments. So let's get started. You'll be provided with two samples. Then the first sample will be labeled C, and your C is lead nitrate. Your C is lead nitrate. Then the second sample will be labeled D. Your D is potassium triazosulfate. Potassium triazosulfate. Then we should not forget that qualitative analysis test is talking about test for cations, test for anions, the flame test, test for individual gases, the appearance of the sample, and the solubility of the what? Of the sample. So now let's start with solubility and the appearance of this sample. Let's look at lead nitrate. Lead nitrate is a white crystalline solid which is soluble in water. So it shows that lead nitrate will dissociate in solution to lead ion. It will dissociate to lead ion and triazonitrate 5 ion. So we should be expecting what? Test on lead and test on triazonitrate 5. So what are the likely reagents that we can use to test for lead ion? The first one is aqueous sodium hydroxide. So we are going to use aqueous sodium hydroxide and aqueous ammonia. Aqueous ammonia to test for lead ion. So for triazonitrate 5 ion, we call triazonitrate 5 ion what? A brown ring test. It is a brown ring test. So we are going to use freshly prepared iron solvate, and concentrated H2SO4. So we use freshly prepared iron solvate and concentrated H2SO4 to test for triazonitrate 5 ion, which is known as brown ring test. Then NO2 gas, that is nitrogen 4 oxide gas, can also be evolved from NO2. So how can we test for NO2? You add concentrated H2SO4, then plus boiling or warming. So you boil, plus boiling or warming. So those are the likely chemical tests on lead nitrate. So let's look at the second sample. So the second sample is also what? Is a white crystalline solid. That is, potassium triazosulfate is a white crystalline solid which is soluble in water. So when potassium triazosulfate dissolves in water, it will dissociate to potassium ion and SO3 minus. So we should be expecting chemical test on SO3. Then what can we use to test for SO3? So we use barium chloride and dilute HCl for confirmatory test. So addition of aqueous barium chloride and dilute HCl for confirmatory test. Then we should be expecting chemical test on SO2 at the same gas, SO2 gas, because SO2 gas can be evolved from SO3 minus. Then what can we use to test for SO2 gas? SO2 gas will give you a choking smell, which decolorizes KMNO4. So we use KMNO4, it will decolorize the purple color of KMNO4 or changes the orange color of K2Cr2O7, that is potassium dichromate. The orange color of the potassium dichromate will change to green. So those are the likely tests that we should be expecting from these two samples. So let's start with sample C. Our sample C is lead nitrate. So we are going to test for lead ion, we are going to test for triazonitrate 5 ion, and we are going to test for nitrogen 4 oxide. So let's start with solubility of sample C. So they will ask you to add distilled water to your sample C. Then you say C plus distilled water. Then C is a soluble salt. So C will dissolve in water to give you a colorless solution. So what will be our observation? We are going to write C dissolved to form a colorless solution. Then what will be our inference for this observation? Then we don't always use solubility tests to test for either cations or anions. So what will be our inference? So our inference will be C is what? C is a soluble salt. So the next one is lead ion. We are going to use aqueous sodium hydroxide. And aqueous ammonia to test for lead ion. So let's start with aqueous sodium hydroxide. So from the solutions C above, you are going to say solution C plus aqueous sodium hydroxide in drops. You will be asked to add in drops. So addition of aqueous sodium hydroxide in drops will give you white precipitate. White precipitate is formed. Then what will be our inference? Not only lead ion that will give you white precipitate, lead and calcium ion will give you white precipitate on addition of aqueous sodium hydroxide. So our inference now will be lead ion or calcium ion is present. Then they will ask you to add in excess. Then you move to another line, in excess. So what will happen in excess if it is lead that is present? So the precipitate, the white precipitate will dissolve in excess sodium hydroxide. So the next stage now, the precipitate dissolved in excess. So the precipitate dissolved in excess to confirm the presence of what? Lead ion. So you are going to say lead ion is present. So let's test with ammonia. So you write solution C plus aqueous ammonia in drops. You add in drops. So what will happen when you add aqueous ammonia in drops to a lead containing compound? It will give you white white precipitate. White precipitate is formed. Then we should not forget that calcium and lead will give you white precipitate. But when you add aqueous ammonia to calcium containing compound, there will be no feasible reaction. So on addition of what? Of ammonia, of aqueous ammonia to a lead containing compound, you are going to have what? White precipitate. So therefore, our inference is what? Pb, that is lead, is what? Is present. Because there will be no feasible reaction with calcium. Then you had in excess. So what will happen in excess? Then in excess. So in excess, the precipitate will remain insoluble. The precipitate will remain insoluble. So another line you write, the precipitate remain insoluble in excess. So when the precipitate remain insoluble in excess, so that is Pb is confirmed. Lead ion is confirmed. Pb is confirmed. So the next one is test for triazonitrate 5, which is known as Brown ring test. And we are going to use two reagents. The first one is freshly prepared iron solvate and concentrated H2SO4. So to solution C plus freshly prepared iron solvate and concentrated H2SO4. So when freshly prepared iron solvate is added to solution C, followed by concentrated H2SO4, a brown ring is formed. A brown ring will be formed at the junction of the solution. A brown ring will be formed at the junction of the solution. So which confirm test for what? For triazonitrate 5. So we are going to write NO3 minus is present. NO3 minus. So the next one is test for NO2 gas. So we are going to add concentrated H2SO4 to solution C. So solution C plus concentrated H2SO4, then plus boiling. Then you boil the mixture. So what will be our observation? A reddish brown gas. A reddish brown gas with irritating smell was evolved. Don't forget that we are testing for what? NO2 gas. So NO2 gas is what? Is a reddish brown gas with irritating smell. Then we are going to confirm the presence of NO2 gas. So the gas turned starch iodide paper blue-black. So to confirm the presence of what? Of NO2 gas. So therefore, the gas is what? Is NO2 from NO3 minus. So we are done with the what? With test for the first sample. That is sample C. Let's talk about sample D. Our sample D is potassium triazosulfate. Potassium triazosulfate. So we are going to test for triazosulfate and we are going to test for SO2 gas. So we are going to test for SO2 gas. So our potassium triazosulfate is soluble in water. So let's first talk about the solubility. So we are going to say sample D plus distilled water plus distilled water. So our sample D will dissolve in distilled water to give us a colorless solution. So D dissolved to form a colorless solution. So therefore, D is a soluble salt. D is a soluble salt. So the next one is SO3 minus, and we are going to use aqueous barium chloride and dilute HCl to test for SO3 minus. So we first add barium chloride to our solution above. So to solution D now, solution D plus aqueous barium chloride. So what will happen on addition of what? Of aqueous barium chloride? We are going to have white precipitate. White precipitate was formed. Then not only SO3 will give you white precipitate, SO3 minus, SO4 minus, and CO3 minus will give you what? White precipitate on addition of what? Of barium chloride. So to confirm the one that we are talking about, so we are going to add dilute HCl. So dilute HCl will serve as confirmatory test. So plus dilute HCl. So when you add dilute HCl, if it is SO3 minus, the white precipitate will dissolve in dilute HCl. But if it is SO4 minus, the white precipitate will remain insoluble in dilute HCl. If it is CO3 minus, there will be effervescence of colorless and odorless gas, which turns lime water milky. But we want to confirm the presence of SO3 minus. So therefore, the white precipitate will dissolve in dilute HCl. So we are going to write the precipitate dissolved in dilute HCl. So which confirm the presence of what? Of SO3 minus. So SO3 minus is present. SO3 minus is present. Let's finally talk about SO2 gas. So we are going to add concentrated H2SO4 to our solution D. So solution D plus concentrated H2SO4, then plus boiling. So what will happen on boiling? A colorless gas with choking smell was evolved. So a colorless gas with choking smell was evolved. So the gas will decolorize the purple color of KMNO4 to confirm the presence of SO2 gas. So the gas decolorized the purple color of KMnO4, or turned, it can also turn the orange color of K2Cl2O7 to green, or turned the orange color of potassium dichromate to green. So which indicates the presence of what? Of SO2 gas. So here you write the gas is what? The gas is SO2 from what? From SO3 2 minus. So the gas is SO2 from SO3 2 minus. So we've come to the end of this class. Please don't forget to like, share, and leave comments. See you in my next class.